Right, question 10, you've got this circle here, and we were asked to find the coordinates of the centre. So remember with that now, you group the x's together, group the y's together, and we then complete the square. So this will be x plus, well, half of that is 1 squared. Take away the square of this, which is 1, and do the same here then. So y, half of that is 3. Take away the square of that then, which is 9 minus 15 equals 0. So you've got x plus 1 all squared, plus then y minus 3 all squared, and minus 9 minus 1 minus 1 minus 9 minus 15 is minus 25. Take it over the other side, so you've got 25. So the centre, okay, for a here, so a, the centre, will be minus 1 for the x value and 3 for the y value, and the radius will be the square root of that, which is equal to 5. Okay, so then part B, it says the line L has equation y equals minus x plus 9. Show that L is not a diameter of the circle. Okay, so we've got to prove that this line is not the diameter. Now if it was the diameter, think about it, this line would go through the center, wouldn't it? Yeah, it would go through the center if it was a diameter. So if it goes through the center, A would satisfy the equation. Okay, A will satisfy this. In other words, this should work in here because it's going through the center. Now if we just go with that and set x to equal minus 1, which is what the x value is, let's see if y does come out to be 3. So y will equal minus 1, because that's what x is, plus 9. Now minus 1 is plus 1, plus 9 is 10. Well, clearly it's not. Okay, when x is minus 1, y is equal to 10. Okay, so it does not go through minus 1, 3. So i.e. will not go through center. So you just need to see if that center point of the circle satisfies this equation. It doesn't. When x is minus 1, y comes out to be 10. It doesn't come out to be 3. In other words, it doesn't go through this point. Okay, so question 2, find the coordinates of the points of intersection of L and C1. So we've got simultaneous equations. Okay, we've got x squared plus 2x plus y squared minus 6y minus 15 equals 0. And then of course you've got your line, which is y equals minus x plus 9. Okay, so we need to then solve this simultaneously. So when we solve, okay, at the point of intersection, the y values will be the same. In other words, y is equal to this, isn't it? So that'll be the case for the curve. So we can sub y in there, x squared plus 2x plus then minus x plus 9 all squared. Minus 6 minus x plus 9 minus 15 equals 0. Okay, so then we've got x squared plus 2x. Now we've got 5 here. Let me just write this out carefully. Minus x plus 9 minus x plus 9. And then you've got minus 6 times minus x, which is plus 6x. Minus 6 times 9 is minus 54. Minus 15 equals 0. So you get x squared plus 2x. Minus x times minus x is plus x squared. Minus x times 9 is minus 9x. 9 times minus x is minus 9x. 9 times 9 is 81. Plus 6x, and then this plus minus this is minus 69 equals 0. This simplifies to be 2x squared. 2x minus 9x minus 9x is minus 16x, plus 6x is minus 10x, and you've got 81, take away 69 is plus 12 equals 0. Okay, now before I factorize this, I think I can divide through by 2, because 2 is a common factor here. 2 goes into everything. So if I divide by 2, you get x squared. Divide that by 2, you get 5x. Divide that by 2, you get 6. And then I can easily factorize this. this becomes x minus 2, x minus 3, which equals 0. So either x minus 2 equals 0 or x minus 3 equals 0. So x would equal 2 or x would equal 3. Now they want the coordinates, so then I need the y values as well, but we'll use this, right? This was the most sensible equation to use here to work out y. So y will equal, when x is 2, it would be, you put in 2 there, so you have minus 2 plus 9, which equals to 7. So there's your first coordinate, 2, 7. And when x is 3, y will equal minus 3 plus 9, which equals to 6. Okay, so you have 3, 6 is the other coordinate of intersection. Okay, let's have a look at the next bit here. Part C, it says the circle C2 has centre 11, 8 and radius 6. Find the shortest distance between C1 and C2. So a little sketch here will probably help. Okay, now they're not touching each other. Okay, they are, obviously there's a distance between them. Okay, so if I've got circle C1, now this is just a sketch, don't forget, right? It's not anything accurate. Circle C2. Now of course with circle C1, I know the centre is minus 1, 3. Okay, that's C1, and circle C2 is 11, 8. Okay, now I know the radius here is 6, and I know the radius there, which I worked out to be 5. Okay, now to get the shortest distance, I basically want to get the shortest distance, and if I line up the centres, that's the best way, right? Line up the centres. The good thing is I can work out the distance between the centres. Okay, I can work out that distance between that centre and that centre. So all I've got to do to get the distance between centres will be using the formula x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so I sub in then x2, which is 11, take away then x1, which is minus 1, plus then y2, which is 8, take away then y1, which is 3 all squared. So I've got 11 minus 1 is 12, 12 squared is 144, 8 minus 3 is 5, 5 squared is 25, so I got the square root then of 169, which is just 13. So I know that overall distance there is 13. Now looking at the shortest distance, I want this here, as I said, as the centres are lined up. I know that's 5, I know that's 6, so if you think about it, 5 plus 6 will be 11. And all I've got to do is take it away from 13 just to see what the gap is in between there. So 2, okay, the shortest distance is 2, just by my reasoning there.